Hey folks, and welcome to Alwa's NES Awakening. This is stream number 19 on a Sunday morning. Making up for last week, we are porting Alwa's Awakening to the NES. We have this awesome background graphic now, thanks to Linus over Bloggenspielen. So we got rid of that boring Windows backdrop, and we've got an official graphic for the project now. We cleaned up a bunch of things last time. Yeah, so we have everything, all the directions working except for up. So it finishes properly on the up, but the scroll is not working, and that's what we're going to work on today. Oh, Bandit. Okay. Familiarize himself with the downward scrolling code. So 2 tile row updates, and then we read the attribute table row, or it in, and write it. First thing we have to do is, I think a lot of the code for up and down is the same right now. And for up, we need to draw the current screen. Boom, boom, boom. One thing we never did was update when the room change is all done. Set the current room equal to the next room. that actually is all the code current, because down cleans up by using the state similarity with horizontal scrolling. So yeah, the way we had it was with up scrolls and down scrolls, it just started scrolling, but we need to get in the proper position first. I think we're going to want I need to, what's going on my, oh, I was going to try one thing because my keyboard always messes up. Hopefully I don't kill my stream here. Damn it. Yeah, I shouldn't have done that. I should not have done that. Okay. I think maybe it's working now. There we go. I have you guys. You guys see me again? Hopefully, yes. It looks like it's back up. I shouldn't be messing with my hubs. Anyway, so we have to sense upward. Let's see. Yeah, we have not. So we're using bit 8 as a go to default bit, which we could halfway use, but then we have to also check for up left bit. And then check other things. And we have to set it first. I don't really want this code here. Whatever. And then we need to just trying to figure out how to handle this. Because we come here if, how do we get, what bits are set to get here? So we know it's scroll dir isn't 0 or none. If the horizontal bit is set, we go to scroll vertical. Now in scroll vertical, we check to see if the go to default bit is set. Or check the scroll bit. And scroll bit should be set. Yeah, because we're setting it to scroll up, down, left, right. So if the scroll bit's not set, then we go to check for the default bit. So we never use the camera bit. We just use the scroll bit and the go to default bit. And then the left or up, down. But Okay. So I don't like the way I'm defining this stuff. It's confusing. But we'll skip all that other code if the scroll bit isn't set. So maybe and this is probably wrong. Up scrolls. First need update name table 0, then 1 top left. So yeah, no, that's right. So let's clear. Or maybe it's weird because really all of this a lot of the active code can be the same for up and down. So we want to check if we were in an initial state. And in reality, well, one way we can do that is change what the scroll up is. Maybe that makes sense. Set the camera bit instead of the scroll bit, because we have to move the camera first and then we can scroll. But we've already checked to see if the scroll bit was set. So maybe we set the scroll and the camera. So we're not using the camera bit for downward scrolls. So hey, second ago, how we doing? I feel like I'm hacking a bunch of code here. So for upward scrolls, the camera bit will be set. need to put nametable 1, so we got to jump through nametable 0. And then I don't want to perform all the scroll code, so I think I just got to jump to forget what I call it. Scroll done. End scroll. I don't know why. Use a local. I got in the habit of always using local. So we need to redraw the current screen. So we need to draw it in nametable 0 first. Scroll count should be 0. Name table 1 is just 2000. Now init pointer. So yeah, I need to change this so it has arguments because I don't want it based on the scroll direction. I just need to copy yeah. I want to get it working first and then change the function. So we're using the current Does it have an extra? Oh. So cur to nat pointer. So okay. This will if we're done, the zero flag will be set. And so this isn't true, but let's see if it did what we want. So I have to scroll down first. Okay, good. Now to scroll up, it should draw. Oh, but it's going to look the same. Let's scroll right. Okay. And it's still. Oh, that's an interesting thing that I haven't thought about. Is the current screen is always gonna also be in nametable 0, except for on init, because we always jump through nametable 0 for left and right scrolls. We scroll into nametable 0 with the next from screen. And for downward, we have to jump through it as well. So as long as the first scroll isn't up, or if we on the very first initialization, if we always draw the current playfield in there, then we can just assume. That simplifies things. And so it's always already in nametable 0. So we only have to do this redraw once, and in the init, maybe we can jump over. But so we should be able to jump over and skip the first redraw. The second redraw needs to be the current play field in this top left corner. The only thing I'm not sure, I don't think we're getting any glitching or anything because the scroll name table value gets written in VBlank, and that will get set. So the next frame will be start rendering with nametable 0, and then we'll be doing updates in nametable 1. Which will then be off screen. So nametable 1. Now I always have to subtract 56 because it's going to pre-increment it. And really we want just 2000. So I don't know if it's going to break some. We might need to set it to, I think we're going to have to set it to 2400. Minus 56. I think we're going to have to set it to 23C8. Because it should handle, it should be doing 16-bit math. Yeah, because it has to deal with 20, 21, 22, 23. So when that's done, now it's going to set scroll none, but that's the time we actually want to start moving the camera. Let's see if, one thing I never did was see what happens. But it's going to be hard to see because, yeah, it redrew, it basically did nothing. All right, so let's, so we can go down. All right. Now, if we go back up, the camera will move over here. It'll start drawing, and all these wells and everything are basically going to move up 4 rows. And then it should put the camera at the top left. Okay. It looks like it worked, except for attribute tables are messed up. Oh, yeah. because draw current play field assumes that you're drawing here. It does the math assuming that. Okay, so we need to fix that. So yeah, here's the attribute table address. So we have to figure that somehow. Okay. So the part of me says check to see if scroll is up. I mean, that's go peek at the global. Which I don't like. But okay, what if instead of so this will be a certain value, right? If we started calling this function not at this, with this being the first address, but with this being the first address. So maybe we could make this not assume if we just make it so that it doesn't, it actually figures it out for itself. It's smart enough, then that would be great. Bandit. It's just him and me today. You right over there, buddy? Okay, so scroll count is 1. Oh, I remember trying to do this now. Trying to calculate the attribute table address based on the name table address, and it's going to be a pain. Maybe we can just check for the two different. So I'm subtracting 8 because it was 8 bytes overextended. Scratch himself on some boxes. Okay. So, well, it was 8 bytes overextended. So I subtracted 8. But in this case, I need to subtract 16 because instead of having the first byte here, I need it to be here. the way that I will know. So if the current address will be end in D0, then I need to subtract 8. But if it's, oh wait, I gotta figure this out. Because the okay. Yeah, the nat, this is the issue. It just happens to be perfect because the last write is not 56 bytes. It's 56 minus 8. I think it's 48 because our play field is 26 times 32. It's 832. Divided by 56 is not even. It's 14. So 14 times 56 equals 784. (26 times 32 minus), yeah, that's 48. So if the address is C8, I don't know the name table, but if it's C8, then it's correct. If it's not C8, what will it be? I don't know what it will be, but I want it to be C0. So part of me says just check to see if it's C8. If it's not, what are you whining about? You're fine. Just lay down. If it's not C8, then we want it to be C0. Start drawing in top row. If PPU header equals 2 C0, else it's special case set to, oh no, C8. Dang it. Okay. So that's name table update. It's the first 2 bytes of name table update buffer, and it's big Indian. So LDA C8. If it's C8, move on. All right. What, Bandit? You're killing me. You can't sit in my lap and me type at the same time in this chair. We gotta go outside. We're just outside, Bandit. It's been hounding me all week. Okay, so that was down. Oops. Going into an area that I can't. Reset here. Come here. You gotta say hi to Bandit. Alright, let's try it. We scroll right, down. Alright, and let's go. Huh. Okay, I think it worked. Yeah, it worked. We just haven't set our scroll. Our scroll value is not what we want it to be. But there's no attribute tail glitches there. So where is that? Well, we need to do it. We need to do it here, where we handle that case. Give it a try, Bandit. Yeah, that's what I thought. Okay. Hopefully it'll leave me alone now. Here, name table 0. I'm sorry, name table 1. Also move camera position. We did that for, I'm just trying to remember what it's supposed to be. If it's supposed to be 0 or 1. So we only need to change the Y. $31. So it should be, I think it should be 0. Let's see it. Okay, perfect. So now we're ready to start scrolling and loading our data. We have the current play field drawn in name table 1 with the top left corner being here. So now when we start scrolling, the first updates we need to do are going to be at the bottom of name table 1. Here's this is actually our buffer. You can see it here that's not being used. So we can start drawing here and fill things up. And when we're done, we'll be in our default position. Okay, good. I take a break in a bit and let him out. Maybe supervise later. Maybe now's a good time to do that. Let's see if that helps the bonehead. So I think we can clear the camera bit now. So we want to clear the camera. Oh, wait a second. We could just set it to whatever it is that we want it. It's that should clear the camera bit. I think I don't want that extra pound in there. Okay. And down should still work, right? I forget which room we're in. Oh. Yeah, it appears to still work. Up breaks everything because of our halfway done state. So vertical init scroll vertical camera. So there's 30 if it's I'm saying if it's 31 it's done, which is true for down, but there was a bunch of code that was the same, and I don't think it's going to be quite the same anymore. So right now it's 0. And yeah, it should be, when we're scrolling up, it should be 31 when we're done. Why was it 31 for down? For down, why does this work? Compare 31, scroll Y. Oh. Yeah. Oh, this is just the initialization. If it is 31, then we need to initialize. Okay, that's what it is. And this is different for up and down. Scroll count should be 0. Are we even using scroll count? We were, I think. Set next init pointer. That's not nametable 0. To be. It's like the bottom of. Oh, I subtract. Yeah. Here I'm. Okay, I think it's supposed to be 0. Let's just see if down still works if we use. So that's initializing based on if scroll count is 0. Okay. Yeah, still works. I just hit up there. It's now executing our new code. So the finish result is good. It's back to where we were, how we were before. Okay. So This is all okay. So for down, we start drawing here. And that's why it's 2C100 minus 56. That's where that 2B number is. But for up, it's actually at the end. Yeah, so all this code is going to be different. Well, because, yeah, we're starting drawing here. For up, it's going to be 27A0 minus, well, I don't know if I have to minus. I did. Why did I? Two BE0 is, oh, I do, it's 30, I think it's pre-decremented by 32. So it should be 2C100 minus decimal 32. Yeah, 2BE0. Yeah. So this needs to be dependent upon if it's up or down. Oh, right there. I need to make myself an error so I don't forget. So up is, it's gonna be 27A0 minus 32. Yeah, 2780, which basically is just, wait, what? Oh yeah, A minus 32, 8, the row previous. Yeah. To ignore him. Two, 7, 8, 0. And so, 2 Sorry. We need to preserve address. Do that regardless. Use scroll count, determine which type of update. So we have to increment scroll Y because the PPU is not incrementing for us, I think. So just want to keep checking to make sure we didn't break down this, hopefully, as we do this. Yep, broken. No, don't do that. What did I do? Oh, hold on a second. This order matters. Yeah, I have to do this here. So yeah. Need this to be okay. Okay, good. I'm just gonna put this down here. Shouldn't have mattered, but I don't trust myself very much right now. Okay. there's our initialization. I'm not 100% sure I have the up initialization right, but that's where it's happening. It's kind of hard to have intermediate tests here other than the fact that we make sure we didn't break down. Okay, so these are the name table segments. So up or down. So for a down scroll, I increment by 32. Where does up scroll go to? There. This is not very well organized. Okay. So I'm incrementing the address by 32. I'm setting the update length to tile row. We're copying over 32 bytes of data. I'm incrementing my pointer, and I'm preserving the name table address. And I'm saying the fill is done. For upward scroll, I'm subtracting by 32. I said 64 up here, and this is... I'm pretty sure that's wrong. Because the address is... Yeah. It's not, the address isn't getting incremented within the function. The address is just an initial address. So we subtract by 32. So if carry set, we don't have to decrement. Okay. And then here, this is where the code got confusing, skipping over attribute tables. But we don't have to do that anymore with the way that we have things set up now. That was why we went through all of those hoops. I don't much care which scroll count we are. We're just going to start drawing the bottom of the screen from here and go up till we're done. That was what simplified everything. So the first thing I do is I decrement the buffer address. I have to set it to updated tile row, and then I copy it over. So we shouldn't need this. This was setting it to a different address. We're setting to a tile row, first byte of data, load 32 bytes. And some of this code may be more easily the same between up and down, but get it working first, I guess. Okay. So okay. So maybe that's good. Yeah. Change buffer address. We set it to a tile row. We copy over 32 bytes. The only thing is is all of our dumb dog. I'm not sure. We had this code up here that we executed. Set nat pointer and init nat pointer. I don't think we did anything. So set next nat pointer. So vertical. So for up, we subtract 2. That looks right. We move the map pointer, and then we load the next nat pointer. Okay. Now init nat pointer probably is broken. So check the vertical. Okay. Initializing the nat pointer. Yeah, see here I'm just automatically doing room 0. Yeah, so we have to move the file pointer, which is the nat pointer, to the end of the data because we're drawing at the bottom of the screen. Let's look at down. So for down, the pointer is proper, but then I have math for the attribute table pointer. Okay. I copy next to working. Okay, that's already done here. So this type of stuff still needs to happen. So I'm setting the nat pointer and the initial PPU address, but that's not something that happens in this function anymore. So I think I'm just going to comment out all of this code. Oops. Okay, so we copy it over, but need to bottom of and so I'm subtracting $32. Not 32, 320. So I'm adding, sorry. So next nat pointer so I load the lower byte, I clear the carry, I add, I store, I load the high byte, I add with carry, and I store. Okay. I have to initialize the attribute table pointer. I don't know if I ever did that. Doesn't look like it. Maybe I gave up because it was such a mess. Yeah, to do set at pointer. Okay, so let's figure this out. So for down, it was the nat pointer plus 340, which gets us to the beginning of the attribute table data. We want to get to the end of it. Oh, we also anyway, we can't forget to consider the fact that the first attribute table update sorry, the first attribute table update is only one nibble row. This one. We just can't forget that. Okay. But the way the data is organized, it's the same. So to some degree, it's almost like we can skip the first one. But the data is structured. This is a play field worth. So it's not 64, it's 56. So 340 plus 56. Which is 38 hex. 56 plus 340, 396. This is actually next nat pointer because we already incremented nat pointer. And I think we can just, well, anyway, doing this math separate is going to be what we want to do. 396, which is hex 18C. So load next nat pointer. We'll do the same type of thing here, just different math. Add. This is the low byte. We're going to add 8C. And store an at pointer. Low byte. Load the high byte. Add 1. Store an attribute table pointer, high byte. So the attribute table pointer should be pointing to this row, these 8 bytes worth of source data. We could add 56 to nat pointer, but I don't see much benefit in doing so. Okay. So that should be fixed. So for the upward scroll, decrement the buffer address, tile update, copy over a row's worth of tile data from the nat pointer. Okay, good. And then decrement the nat pointer by 32 for next time. Okay. Now, for an attribute table segment, first we do a read. And I'm using scroll count. And this probably works for down but not up. Let's we shouldn't have affected anything in the down scroll. Let's make sure that's okay. So what did I do here? We want the attribute table address. So I have scroll count. This works for down, but I don't know, this thing's gonna work for up. I just executed this code though, regardless. So all I'm doing here is setting the mask that I want to use inside the NMI to determine which. Okay, so it's this mask. If we just assume the 0 the first time, the bottom for downward scrolls, the first time we're going to do the top, which is the lower byte. For upward scrolls, it's also going to be the top because there is no bottom here. So for 0, it's always going to be the top, and then it'll alternate. So I think that mask will work for up and down. Down scroll, first time update, okay. So we set the mask. Now here, I'm branching if it's up or down. So for the downward scroll, I determine the address here. Oh, I just always add 2C0. Bit 3 and above determines the address. I multiply by 8 and I add it to the beginning. Okay. For up, special cases, which we shouldn't have anymore. So I have all these check which segment it is. And for segment 3 and above, okay, I'm going to steal the downward code and try to modify that. Okay, so the segment determined the attribute table address for down, because for down we said, oh, okay, segment 0 is these two rows, right? If it's 0, then we just add the attribute. The attribute is shown up here when I highlight it. So 2F C0, well, and actually you can just look at the name table 1, not 4 or 3. Yeah, 27C0. But our segment counts go backwards. They go up, upward scroll. So the first one is going to be 27F8. So if segment is 0, it's going to be 27F8. And segment 1, it's going to be 27F8 minus 8. And same for 2. Just the other nibble. So we want it to be 27F8 minus the segment. I did, for downward scroll, we did 27C0 plus the segment. And for here, it's 27F8 minus the segment. Two 7F8 0. So what I do here, so I have a contained the address. We want it to already be there, and then subtract 8 or subtract the segment from it. So let's pre-store it. Um, 27. And this is big Indian because that's how it's written to 2007. So 27F8. So it's already in there. Now we can subtract. Oh, wait a second. Subtraction's a pain. I think we want to use 2's complement. We want to add the 2's complement, which is subtraction Or can we just put it in a register? What are our subtract options? So we can just subtract the 0 page value. Oh, we're using reg 0 for the I don't think we need it. I think we can use register 0 again. So reg 0 contains the byte number row. Subtract. So I doing your ironing wash. That's good. Multitasking. How are we doing, Voxel? So load F8, subtract, we'll clear the carry, reg 0. Now reg 0 should be, well, the subtract, we have a 16-bit value and we're subtracting an 8-bit value. So we store that in nametable update 1, and then so let's do this. Let's store the upper byte. Subtract and store lower byte, and then branch of carry set. Oops. So we need to decrement if a carry, or I'm sorry, if a borrow occurred, the carry will be clear, and we need to decrement nametable update. I don't even know if that is that going to happen, because what's our address range? It actually should never happen, because I don't think we need that. Save some instructions. Why not? Probably to not insert some bug. What was that? Okay. So, oh wait, this yeah, we want to we do have to clear the carry because otherwise it'll subtract an extra one. We just shouldn't have to worry about if, right? I always get that. Yeah. Okay. So that hopefully works for reading the attribute table address. Now we have to, so these are those special cases that I don't think I care about anymore. Only thing is I don't know if this is actually correct because the downward we can mask out the lower bit. We don't care if it's odd or even to determine the address. But here it's almost as if we have no 0. We only have, we start at 1 because there is no bottom row here. So we're off by 1, I think. I guess I need to understand what's the math that's actually happening then. So reg 0 we started up here. So scroll count 0 and 1 determine the frame count, and we don't care about that. So we shift those out. A contains the segment count. Bit 2 determines if it's upper or lower nibble. And then I shift out that bit and store it in reg 0. What if we do this? So bit 3 determines which mask we do. And if it's 0, it's going to be upper. I think that's all well and good. But for here, instead of doing this, we're going to load reg1. So if we increment register 1 and then load it, and then I think this works. I don't know how to explain it well, but we're starting with 1, not starting with 0. I doubt I got that right, but maybe. Okay, so none of this. Whoops, what did I do? So for write segments, now NMI just went and read the current attribute table bytes and stored it. It masked out the bits that we want to update, and it stored it in the buffer. All we really need to do is change that buffer. I don't think we need to change the address or anything like that. So we use the mask to determine which one we're updating. So we already determined that. So I think register 0 contains the mask. First byte, use the attribute table pointer and copy it over. Increment, decrement the pointer for next time. I'm saying only do it for odd segments, but for upward, we need to do it for even segments, because we start with right? Or wait a second. So it's a post increment for next time. And for segment 0, we need to increment the pointer so that it happens next time. Up, subtract 8. Only for even. Decrement for, oh, this is difficult. Yeah, in the file. But based on what we did just now, based on how it's up now, it shouldn't be as bad. So we need different code for up or down. So here I determined if it was an odd or even segment. Okay. So I load scroll count, check and with 1. So here for even segments, I jumped. Here for odd segments, I'll jump. I load the attribute table pointer, I subtract 8, I store it. If there was a carry, I'll skip. I'm sorry, if there's a borrow. Otherwise, I need to decrement the most significant byte. Okay. Wonder if it works. First time? Probably not. It did a whole lot of code. All right. Scroll right. Scroll left. Scroll down into the wells. Scroll up. Not so much. All right, let's step through it. We'll scroll. All right, so let's scroll down in here. And scrolling back up to room 0. I don't know how to get. Let's do this. Scroll down. Start the debugger. Start the behavior. Render frame. Okay. Up. Render frame. Turn that off. All right, F8. Switches over to the nametable 0. And it draws the current screen in nametable 1. Jumps over there. Good. Now it should start updating these tile rows, and we're not really going to see it right away, but that's what should happen. Oops, what's it doing? It looks like it's off. It starts here. But it's not even the right. What's that screen supposed to look like? It's supposed to be 4 rows of bricks on the bottom. And what's it drawing? It looks like it's drawing here this data. It looks like the file pointer's wrong, because it draws this row and then it draws trash. And it's not doing it in the right spot. It's supposed to be doing it here. Then what does it do? Start scrolling. What is that? A can of peas or something? I don't know what that emoji is. So that was an attribute table update. It does tile, tile. See, some of that data looks good. Oh, I couldn't find a trash can. Regular can. There we go. Yeah, just getting trash. But it looks like we have good data here. Maybe it had bad data, but right now it's updating right here. It's too far. It's too far up. But I'm having a hard time seeing what's exactly happening here. Okay, so that was an attribute table read, write. It looks like it wrote the attribute table in the right spot, because it should be on this leading edge of the camera here. So tile right, tile right. I think what it's doing is, I bet at my initial screen load happens to be directly above. So it's going to be drawing the wrong screen because it's all off. We can tell. Yeah, see, these are big bricks. Yeah, so my file pointer is wrong. It looks like maybe we were calculating the attribute table address to update properly. So let's, the tile address is definitely not source data. The tile source data attribute table pointers, name table pointer is definitely not right. Let's look at this. We didn't actually break down, right? Okay. So set next nat pointer init nat pointer. So I load scroller, I check for the up bit. All right. So I load next nat pointer, which should be set based on the previous function call. Hey, add three two zero. And I store it. Oh, but does it need to be? I did the same thing as last time, but or what the code that I had previously, but I'm not even sure that was working. It should be, what should it actually be? We have 26 rows, 32. So there's 300 or hex 340 bytes worth of tile data. But as we scroll through, we're decrementing by 32. So I think we need to pre-increment by 32. If I'm correct, then it should be 360. Because when we start loading up data, we start by so for up scroll, we load the address and we subtract 32. But that's for the buffer address. And then for the data, we load with the nat pointers. And then we subtract 32 for the next time. Yes, there isn't actually a there's no pre-decrement of the pointer. We set it to the data that we want. So instead of 3, I did 320, but I think maybe it's supposed to be 340. Yeah, see, I what did I do for down? I don't do anything, right? Because it's already pointing to the exact data that I want. But for the attribute table pointer, I add 340. So 340 gets you to the end. So I do need to subtract 32 to get it at the first row of data. Yeah, so 340 bytes tiles minus a row is 320. Wind blowing, making some weird whistling sound. Okay. I guess I'm not sure if next nat pointer is actually set properly. No, hold on a second. Okay, yeah, it's a horizontal bit. I load scroll dir. So the down adds 2 to the map pointer. Up subtracts 2 from the map pointer. Load next. Might just have to do a breakpoint on where do we want the breakpoint? I don't want recording. Dang it, Vim. Let's so let's go to up. Scroll init. if we... I can never recognize my code when it's in this. Okay, so if we if we break here, well, we had multiple issues. Excuse me. Not only was our source data incorrect, the place we were putting was incorrect. We want to start drawing 27A0. But I pre-decremented the PPU address, which actually isn't correct. Getting things confused here. Right? Because what do? I start by incrementing or decrementing. Oh, yeah. So it goes ahead and subtracts 32. I'm thinking down. So I want to pre-increment because it's going to automatically subtract 32. Okay. So 27A0 plus 32, which should be 2C100. I'm just going to get rid of these notes. Okay. How do I change which bank? I have the wrong bank visible. CHR selection. I want it to be the second bank. I don't know how. I have to ask Sour or something because tile address. You would think or maybe I have to render a frame. What if I do that? If I render a frame with, I want to change when emulating show PPU data scanline 231. If I close everything out, no, I need to get everything exactly how I want it. Scroll down, then open the debugger in the PPU viewer. then I can do a single frame and it will show me the bank of CHR that I want. Skips over, draws data, jumps over. All right, so the first should be updating here. I don't think that we fixed the file pointer, but at least it should be updating the proper location now. Oh, boom. See, it updated attribute table data of nametable 0 instead of tile data. What the heck? Oh, it's not 2C100. I think it's 2800. That's why. Because 27A0 plus 32. 27A0 plus 32. Oh, 27C0. Yeah, which is basically attribute table data. But it's going to subtract. Okay. Yeah, math, Paul. 27C0. I gotta close this stuff out. Reload. Get to the screen I want. Then open these guys up. Render frame. Up. Render. Turn that off. Okay. Okay, so it should start drawing here, and we won't actually see anything. Tile. Tile. It's doing it in the right spot. It's the wrong data. Attribute read, attribute write. Tile, tile, attribute read, attribute write. Tile, tile, attribute read, right. Okay, it's doing it in the right spot now. Our pointer's just messed up. That's not what I want to do. Get this done. Boom. All right. What do our pointers look like? So, next nat pointer, cur nat pointer. And we're going into room 0. Yeah, I think I upgraded my missing. Oh, yeah. I downloaded the new Messin, the latest build. Last stream I was having some issue where it was crashing on me, but I don't think I switched over yet. Yeah, I haven't. I think it's always saved my watch list. I've only been doing things for a couple months here. All right. So where is our room data? Why can't I see it? Labels. Oh, it's not a local. Yeah, I kind of do the same thing. But you miss out on features too. Okay. So room 0. So the next nat pointer looks correct. But the working pointer is not. I only subtracted. It's not incremented to the end of the data. Did I not? Why not? It looks like it's down data or something. Now the attribute table data is incremented. I don't know if it's a 28764. So it's at the beginning. This looks like it's initialized for the down instead of the up. So let's set a breakpoint on that code. Init Okay, so I think is it this one? Let's check down. Here we go, up code. Scroll left, right, down, and we should get a breakpoint when we hit up. Boom. Okay. So next nat pointer points at room 0. That's correct. So I load it. Clear carry, add, store. Wait a second. Am I getting Indians messed up again? Yeah. This is Little Indian. Dang it. The low byte. Wait. Hold on a second. maybe that's right. 20, yeah, okay, yeah. 24 plus 20 is going to be it's 8424. Is 44. Okay. It's going to load 84, add 3, store it is 87. So nat pointer 8744. That should be towards the end because attribute table data starts at 8764. 8744, yeah. Okay. So it's, yeah, that sounds right. Now it should be updating the attribute table pointer by 85B0. Oh, that doesn't sound right. 85. Room 0 attribute table data starts at 8764. Nope, not Wednesday, but we're making up for last week. Missed it last week, so with those 5th graders. Why? Oh, that's why. Gosh, Paul. Well, I think there's a problem there, but I just went ahead and executed I lost my RTS. You know, I did that when I was doing it too. Damn it. I'm still not sure that address is correct, though. Attribute table data. Oh, maybe that's, wait. It should be really close to room 1. It should be something like 8790. Yeah, so why is my attribute table pointer wrong? I load nat pointer 24. I add 8C. 18C, is that right? How did I get that number? Yeah, that's not. That's not right. I don't know what the heck I did there. It's 832 plus 56. That's all of the data. That's 888, right? That's the entirety of the data. I want to subtract 8. So it should be 880. Convert to hex is 370. $880, which is, what did I say? 370. Well, 2 bugs, 1 fix, hopefully. So the low byte subtract 70. All right. I think I can turn my breakpoint off. Let's just see if it works. Maybe. And go. Oh. It worked, except we had a little bit of a jitter there because it wasn't the scroll position. I think is getting messed up with the attribute tables. We don't have the Oh, our math. Yeah, our math for the scroll position is going to be wrong. We start at 0. Yeah. Okay. That's cool though. Oh. Well, the other situation is I think we have this go to default. When this is done, it's done. So let's make sure we're ending properly. I'm just going to delete this code. Maybe not yet. Okay, vertical exit. So I'm saying the go to default bit, but really we only do that for down. This might be part of why the scroll looks bad. Maybe our scroll isn't actually wrong. Oh, we also need to copy cur over to What are you doing, Bandit? Bonehead. Just go back to taking your nap, buddy. This code is a little confusing. Okay. 940. Oh, it's 1 o'clock already. I probably only got about 10 minutes or so here, so up, scroll, subtract 4. See if we can fix this quick. So we load scroll Y, we subtract 4. If carry was set, because it should be, scroll Y should be 1 right now. Okay, and this is why it ends compared to 64, but we don't want to actually compare to 64 anymore. It's 32. Come on now. Hey, I think, oops, don't do that. I think we got it. Let's pop that sucker. I know, Bandit. We're almost done. Pop that on the cartridge. And oh, I think I broke my code. Messing around with. Oh, maybe not. Okay. Nope, that's all. You can't even see that camera's locked up. Whatever. Let's just go without the CRT. All right. So this is a recap of stream number 19, I think it is. We set out to clean up the upward scrolling between rooms, and by golly, I think we did it. Okay. So we can show we still have our map of I'm gonna get the orientation wrong, but 0, 1, 2, 3. So we have our map of 4 rooms. We can scroll right into the dead tree room. We scroll left back into room 0. So this is room 2. Room 0. We can scroll down to room 1, the wells, and we can scroll right into room 3, the evergreens. So we had that working before. Left, right, down. Now we can scroll up cleanly back into room 0. I will step through it here quick to show it in operation. And looks like we have to actually be in a bottom room. Okay, so we'll start here. Trigger an upward scroll. All right. So the first things we had to do, it was the whole reason that we stopped doing the working on upward scrolls over a month ago, because of dealing with that attribute table gap at the bottom of the name table. That wraparound is a huge pain. So we change our current. So right now we're displaying off of this name table 1 from this top left down to here. So we're going to go through name table 0 and then redraw and have the start of the scroll happen right at the seam. I realized that by default, the current play field, because of the way that we do all the other scrolling, is always going to be sitting in name table 0. So first thing, all we have to do is change our displaying name table to 1. So there, 1 frame, it jumps over because it should already be there. Then we have to redraw the current play field with the top left corner here. So that happens. And once the color data gets updated, then the screen jumps over. So now the top left corner of the play field is being rendered from the top left of name table 1. Now we can start our actual scrolling. So the updates are going to start happening here. We'll do our 2 tile rows. You can't see it there. Read attribute, write attribute, and it starts scrolling. There you can see it updated this row here. Now it'll read attributes, write them, keep scrolling. So 2 tile rows, then attribute. And so that is being hidden off screen. And you can watch this and there shouldn't be any glitches, because the updates are being made in our 4-row buffer that accounts for the heads up display. And we're done. Once we get there, there's no going back to default. We are in our default. So up is a little bit backwards and everything else. And yeah, so cool. We did it. We now have, whoops. We now have a fully functioning, oh, I don't know. Maybe not. Can we do a down, up, down? Okay, so there's something that still broke. Some sort of initialization is, I'm just going to close this. Messing's being weird. Let's try it one more time. Okay. Right, left, down, up, down. Yeah, so something's not quite right there. I'm not, I gotta figure out what it is that I'm not resetting. Down works, but it's either that it only works once. Oh, that's one thing I never thought about. If we scroll down, it'll just keep stepping through the rooms. So it looks like down works more than once. Huh. Anyway, there's some something that we're not in it, post, something we're not clearing once an upward room change happens. It works, it's just, and it can do a left-right. It just can't do it down again, so I'll have to figure that, hopefully small bug out next time. But thanks everyone for tuning in, and we should see you again on Wednesday.